Right, welcome to my video on Measurement and Geometry 3.3, basically on the Pythagorean Theorem. I applaud you for taking your own initiative to relearn the Pythagorean Theorem. And so if you can read what I wrote over here, I'm basically going to be giving you 4 different sample problems. They will be getting harder and harder as we progress. And before each problem, I do want you to pause the video and try to copy the problem down and work it out on your own before you watch me work out the problems. As you see here in the red, just watching me work out these problems is not going to be enough. You do need to be practicing the problems to get really good at it. So here we go. My first page. Let me just explain the Pythagorean theorem. The Pythagorean theorem basically applies to any right triangle. It has to have that right angle in there. It has to be a right triangle for the Pythagorean theorem to work. And this side here is called a leg on a right triangle. That's the A. Here's another leg, the one in the purple. That could be the B. The A's and the B's can be switched around. The yellow side is the longest length out of the 3, as you can see, and that's assigned as the C, and that's called the hypotenuse, and that's a vocabulary word that you do need to know. Hypotenuse. Hypotenuse is the longest side of a right triangle, and that is the side that is always assigned as a C in this formula, a squared plus b squared equals c squared. Remember, the squared means it's an exponent. It means basically a times a. And this obviously means b times b. And this here, c squared, obviously means c times c. So the Pythagorean theorem, if you look at this example here, this length is a 4, that length is a 3. The Pythagorean theorem does not mean 4 plus 3 equals to 5. Obviously, this length of 5, if you add the 4 plus the 3, obviously that does not equal to 5. What it does mean is 4 squared, let me see here. It does mean 4 squared plus 3 squared equals to 5 squared. And if I were to multiply 4 times 4, that's a 16. 3 times 3 is a 9. And does that give me a 25? Absolutely. 16 plus the 9 does give me a 25. And 25 does equal to a 25. Okay? Another way of looking at it is, see how this length is a 4? If I were to create a square that is 4 by 4, can you see how the purple boxes, there's 4 boxes here, there's 4 boxes there. So it represents a square of 4 by 4, and 4 times 4 is obviously 16. And that's basically the area of the square that is 4 by 4. And if you look at this length here, that's a 3, and here's another length, that's a 3. 3 times 3 gives you a square of 9. So the area here is 9. 3 times 3 is 9. And what they're basically saying, the Pythagorean theorem, a squared plus b squared, is basically saying 16 plus the 9 will give you the c squared, which is 5 times 5. Notice how this length here, and here's a perpendicular side that's also 5. 5 times 5, which is where the formula comes from, is really the square that's created, and 5 times 5 is a 25. And you notice that the 16 plus the 9, if we're to put all of these boxes in here to demonstrate, there's 16 boxes, 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15, 16. Here's the 16 boxes that went in here, and the 9 boxes will be able to fit in the remaining 1, 2, 3, 4, 5, 6, 7, 8, 9. And so that's the Pythagorean theorem. A squared plus b squared equals to c squared. And let's see if we can work out some problems here, okay? So here's your first problem. It's asking you, what is the missing length in the right triangle below. Remember, it only applies to right triangles. You do have to have a right angle in here in order for it to be a right triangle. If it does not, the Pythagorean theorem does not work. So the first thing, we're given this length. This leg is 6. This leg is 8 centimeters. We're looking for this length here. And so pause the video at this moment and copy this problem down. Try to work it out on your own first before you unpause it here, okay? All right. Okay, so hopefully you attempted to work out this problem on your own. Let me just demonstrate the problem for you right now. Notice how the right angle is here. And the first thing that you got to know is to identify the hypotenuse. And the hypotenuse is the longest length of a triangle. And here is a clue or a hint of how you can figure out what the longest length is. Because the longest length is the C in your formula here. So notice how the right triangle here, the right triangle always points to your hypotenuse. So that length is your hypotenuse, and that length is going to be the C. Okay? That length is going to be the C. So let me demonstrate. There's two ways of going about it. I want to first demonstrate it using the actual formula itself. And so the formula was a squared plus b squared equals to c squared. We did say that this was a C. The A and the B can be anything here. This could be the A, this could be the B. And so we're just going to plug the 6 in here, 6 squared plus 8 squared. Okay? So it's basically 6 squared plus 8 squared equals to the C squared. And so we start evaluating. 6 squared is 6 times 6, which is the 36. 8 squared is 8 times 8, which is 64. We add them together, and we end up with 100 being C squared. Now remember, it's C squared that is 100. And what do I do next? What I need to do next is I actually need to, I want to know what C is, not what C squared is. And so what I need to do is I need to take a square root of both sides. Remember that whatever you do to one side of an equation, you do need to do to the other side, and it does not, it'll hold the equality of the equation here. So I'm taking a square root of the C squared, which is C, because C times C does give you a C squared. And what times what would give me 100? It has to be the same number here, so it's actually 10 times 10. So C is 10. And so my answer is C equals to 10 centimeters. And please make sure that you always include the unit as well. I do want to show you how to do this using the picture where we create areas out of these. And so let me see here. Won't be the, let's start around here. So if I were to demonstrate using this here, notice how this length here is 8 centimeters long. So I'm going to create a square that is also 8 centimeters this way. And here is, that's about, no, I think I need to make it a little longer than that. Here we go. Here's 8. So notice how I've created a square. That is 8 by 8, basically. That length is an 8. And so this length is also an 8. Okay, so 8 times 8 will give me a big 64 centimeters squared. That's the area of C squared, 64. Okay? Next, on the other side, notice how I have the 6 here. And so the 6 here, I'm creating basically a square that is 6 by 6. And notice how this length is a 6, and I've created another, what do you call it? A side of 6 to have a square, a perfect square that's 6 centimeters on each side. And so 6 times 6 is 36 centimeters. And that's where this comes in, the 6 squared. Okay? And lastly, here's the unknown side that we're looking for. And the unknown side should also have a square, if we're following this method here, that is about the same length here. Okay, and I think we're kind of crossing into this, but that's okay. So the unknown length times the unknown length is going to give me the c squared here. Okay, and so you got to be asking yourself, out of these three squares, which one is the biggest? It's the one that has the hypotenuse in it as a length. And so obviously you can kind of tell visually, if you've drawn it correctly, or pretty, if you estimated it well, that this is the largest square out of these two. And so the Pythagorean theorem, if you remember, the one with the hypotenuse is the biggest square. The two squares, the sum of these two areas, is going to equal to the area of this big square. The 36 plus the 64 is going to give me the c squared. Okay? And so this really is 100 squared. Oh, I'm sorry, not 100 squared. It's really 100 centimeters squared. And so you end up taking the square root of that, and that really is, that does give us a length of 10 centimeters. Okay? So either way you look at it, it holds true, and hopefully this makes a little bit more sense to you here. Let's try another problem here. So once again, pause the video, copy this problem down, and try to do this on your own, and then unpause it, and let's work this out here. Okay, here we go. So we've got another right triangle that is 5 inches. This leg here is the unknown, and we've got this here, this side being 13 inches. Now, the first step you should be asking yourself is, which one is my hypotenuse? Once again, the hypotenuse should be the one that is opposite of the right angle, and it is the longest length. So I'm not going to reveal what length that is as of yet. What I do want to do is I want to, first of all, before we figure it out, using the algorithm, I do want to show it to you pictorially first. So let's see here if I've got enough space here. Okay, so I'm going to first of all draw the little triangles once again. So if this is 5, this is going to be about 5 as well. This is going to be about 5, and here's my 5 by 5. Okay, my 5 by 5. And let's just keep the colors consistent. If that's 5, this is going to be 5 as well. 5 times 5 is obviously 25 square inches. Okay, got 25 square inches. My next one here shows, this one's the unknown. 1, 2, 3, 4, 5, 6. 1, 2, 3. Okay, so it should be around here. Should be around here. Here it is. Here's my square. That is the unknown. The unknown times the unknown is going to be whatever that is. I don't know what it is yet. Here is my other one. Let's see here. How can I do this? I want to be kind of somewhat accurate. Oh, I can't do that. Okay, so remember, this square has to be perpendicular in order for it to be a square. It should be perpendicular. It looks like it's kind of go off the page, but that's okay. All right. Now, this is going to be 13. This length is 13. So this length is actually 13 as well. And so 13 times 13 is 169. So that's 169 square inches. And now you step back and you ask yourself, which one is the hypotenuse once again? Was it the length that's 5? Was it the length that's 5? Was it the length that's 13? Or was it the unknown length? And if you look at the squares, it might be hard to see, but which is the biggest square out of them all? Is it the one that's 25 square inches? Is it the one that's the unknown? Or is it the one that's 169? And the 169 is the biggest square, actually, which tells you that this here plus that has to give you 169. So how do I figure out what this amount is? That amount would be the 169 minus the 25 that you see here. Okay? And so that's going to give you a total of 144. Okay? Does that make sense? The 144 plus the 25 has to give me the 169. So in this instance here, we actually had to subtract rather than add like we did on this here, where we added them together. So let's take a look at the actual algorithm here. And so we'll calculate this out. We start off with a squared plus b squared equals to c squared. Okay. The a squared, the a was the 5, so that's 5 squared. The b was the unknown, so I'll just use b squared for the unknown. The c was the 13 squared. Okay. Once again, the c squared is the hypotenuse. The hypotenuse is your longest length. The longest length is obviously this side. It's not the blue line. It's the red line, actually. That is the longest length. How can I tell? Once again, look at where the right angle is. The right angle is kind of pointing to your hypotenuse, which is the longest length. Okay? That will always be your c. So you do need to make sure that it's plugged into the right spot in the formula. We start solving it. That's a 25. That's a b squared. That is a 169. And so basically 25 plus the unknown equals to 169. And so if you remember the rules for your equations, you do need to start. The purpose is to solve for b squared, or for b, I should say, specifically. And so you end up, first of all, minusing 25 on both sides. Okay? Whatever you do to one side of the equation, you do to the other. The 25 and the minus 25 cancels out to a 0. It zeroes out. And you end up getting just a b squared on one side being equal to the 144. Okay? And then from here, you need to actually, once again, take the square root. You need to take the square root of both sides, because whatever you do to one side, you have to do to the other. And you end up with an answer of b equals to 12. And that was 12 inches. No, was it inches? Yes, it was. 12 inches. Okay? And so your answer is 12. So this length is 12 here. 12 inches. And we're able to get that answer. If you were not, try to redo the problem again. Start from scratch, draw out the problem again from the beginning. You might want to rewind the video a bit to see what the dimensions were, and try to work it out again. Anyhow, let's move on to the next problem here. And the next problem here says, in the figure, here's my figure here, D, and look for the D. D is right over here. Can you see that? D is the midpoint of A to C. That's a line segment of A to C. Look for A. Here's my A. Here's my C. So this whole line segment, in this whole line segment, which is 16 centimeters, the whole length here is 16 centimeters, they're telling us that D is the midpoint. What does that mean if it's the midpoint? It means from A to D is equal to D to C. So let me just kind of note that here. Length segments A to D is equal to the length of D to C. D to C. Okay? So that length is equal to each other. So that's the first clue that they gave us. And now the other clue that they gave us is that length B to D. Here's the length B. Here's the length D. This line segment here, B to D. is perpendicular. Perpendicular. It is perpendicular to A to C. Here's A to C. What does perpendicular mean? It means that it creates a right angle. That's what it's telling us. They're telling us that this here is a right angle. Okay? Now that's going to be very important here. What is the length of B to D? What is the length of B to D? So they want us to find this length here. Let me just mark that in green. That's the length that we need to find. All right? That's the length that we need to find. So how do I solve a problem like this? Well, remember, Pythagorean theorem only applies to right triangles. And do we have a right triangle in A, B, and C? No, that is not a right triangle. Each of these angles none of these angles are 90 degrees, and so it's not a right triangle. However, if you look at half of this triangle, notice that they gave us the fact that this is a right angle here, and so this half of our triangle is actually a right triangle. So let me just kind of color that in. But this triangle here that I highlighted in yellow actually is a right triangle on its own, isn't it? So this is where we can apply the Pythagorean theorem. Now the question is, how do I know? Well, we know that this length here, B to C, is 17. They gave us that it's 17. What is that? Is that a leg or is that a hypotenuse? Well, where is my right angle? My right angle is right over here, right? And once again, my right angle is pointing to my hypotenuse. So that 17 that you see is, my C. Okay, so this is going to be my C. Now, the unknown, the green line that you see here is the one that we're looking for. So we need to actually know what this length, we need to know what this length is before we can start solving or applying the Pythagorean theorem. Well, we were given the fact that this length, A to C, is 16. And remember, D was the midpoint, which means it halves it. So based on that fact, the length of D to C has got to be 8. Right? It has to be 8. So this length here is an 8. Okay? 8 centimeters. So I've got 8 centimeters. I've got the 17 centimeters here. That should be pretty easy to figure out what that length is there. So let's begin. A squared plus B squared equals to C squared. What is my A? My A, why don't we just assign this unknown length as my A? So that's going to be the unknown. That's what I'm looking for. What is my B? My B is this 8 centimeters here. So it'll be 8 squared. What is my C? My C is the 17, which is 17 squared, which was my hypotenuse. So once again, A squared plus the B squared has to equal to my C squared. We start doing the math. A squared doesn't change. 8 times 8 is 64. 17 times 17 is 289. Okay. By the way, when you do many of these problems, you kind of start memorizing what the square of certain numbers are. Like what the square of 13 is, 14 is, 15, 16, 17, so forth. Anyway, continuing on, what do I do next here? You need to isolate the variable, so you get rid of the constant here. You subtract 64 on both sides, because whatever you do to one side, you do to the other. You end up with having just A squared equals to 225. Okay, you take the square root now. Once again, you take the square root of both, and you end up getting A equals 2. What times what will give me 225? It's actually 15. So A is 15 centimeters. Okay, 15 centimeters. So that's my answer. A equals to 15 centimeters. All right? Questions on this? Once again, you would have been able to see the relationship of, if I were to have extended this out, this would have been 8 times 8, okay, which is a 64. Um, this here, excuse me here, this here would have been 17 times 17, which is 289. And then it's a matter of figuring out what, oh, that doesn't look like a square. Yikes. Trying to figure out what this length times that length, what that square is. Okay? And so if this here is 289, if this is 64, you know that this squared plus that squared has to give me 289, which tells you that you do have to subtract. And you end up with 225 here. Okay? 225 squared is obviously 15. So my answer is 15. How is it coming along so far? Are you getting this? Well, let's move on to one more problem here. And this problem is probably one of the toughest ones. It says here, let's read this here. Actually, can you pause this first, write out the problem, and try to figure it out on your own? Okay. Okay. Let's continue on here. In the figure below, line segment A to B, where is A to B? A to B is A is here, B is there. They're telling us that line segment A to B and C to D, where's the C? Here's the C, here's the D. So this line segment there are perpendicular. So this length and that length are perpendicular, which means that it creates a right triangle, doesn't it? What is the perimeter of triangle ABC? A, B, C. They want to know what the perimeter is. Now, this sounds pretty easy, doesn't it? Perimeter. Perimeter basically means the sum of the lengths of all the sides. And in a triangle, we have 3 sides. So we've got to add up this length, which is 21. We've got to add up this length, which is 17. And we just got to add up this length, which is the unknown. And so if I can figure out what line A to C is, I can find my answer, can't I? And so what I'm going to do is I'm going to underline the question, because ultimately, this is what I got to come back to. I got to be able to answer this question that tells me what is the perimeter. Okay, I'm looking for the perimeter. So how do I begin? Well, if you're not thinking too carefully about this, you might end up doing this. A squared plus B squared equals to C squared. Let's see here. I'm going to set the red as my A squared. And then I'm going to add the 17 here. 17 squared equals to 21 squared. And I'm going to try to figure this out. Is that what you would have done? What did I do wrong here? Well, let me see here. Let me just keep going here. 17 times 17, 289. 21 times 21, 21 times 21 is 441. Okay, and so you end up subtracting 289 on both sides. What do I end up getting? A squared equals 2. 152. And now I need to square root the 152. I need to square root, and then you end up getting stuck. It's like there is no perfect square for 152. Like what times what will give me 152? It's not going to be a perfect square, that's for sure. Here's the thing. What did I do wrong to begin with? What did I do wrong? What did I do wrong? What I did wrong was I can't apply this formula here. Why not? The Pythagorean theorem is only for right triangles. And if you look at this angle here, this angle here is not 90 degrees. This angle here is not 90 degrees. And that angle here is not 90 degrees. And so I can't apply the Pythagorean theorem to this one triangle here because it is not a right triangle. So this here is no good. Okay? Get that? You can't use it. So let me just rewind. Oops. Okay? And let me go back to this here. So what do I need to do? Well, this problem takes a lot more work than you think. What we can do is we can, first of all, we were given this whole length, we're given this length, we're given this length. Um, Notice how this is a right triangle. Let me just highlight it in yellow here. Notice this right triangle here. Can you see the right angle that was given to us? Sure. And this length here is an 8. That length here is a 17, right? And then we are looking for the length that's right over here. That's the unknown, which is my hypotenuse. Hypotenuse, look for the right angle. Here's the right angle. Once again, it's pointing to the hypotenuse. Here's my little beginnings of an arrow. This length here is going to be my hypotenuse. Alrighty? So let's start by writing out our formula here. A squared plus b squared equals to c squared. Okay? I've got a as 8 squared. Here's my 8. Okay? My b is going to be the unknown. So b is going to be the unknown. Okay, this is the length that I don't know what it is. That's a b squared. And the c squared is going to be my 17. Here's my c squared. Here's my c, excuse me. And so I need to square that as well. And so solve it. 64 plus b squared equals to 17 times 17, which is 289. Okay. Then I would have to subtract 64 on both sides to isolate my variable. My variable is getting isolated. It's b squared minus 225. Okay. You need to square root both sides. Whatever you do to one side, you do to the other. And I end up with an answer of b equals to 15. Okay, 15 feet. So I figured out that this here is 15. Now, if I know that this length here is 15, and the total length here, the total length is 21, I can just kind of figure out 21 minus the 15 feet is going to give me 6 feet. And so basically I just figured out that this length here is 6 feet. Okay? Since this is the whole length is 21, this portion is 15. 21 minus the 15 is going to give me the 6 feet here that you see. Okay? Does that make sense? Okay. If any of this part confuses you, pause the video and try to think about what I just did. Okay? Make sure that you are understanding and making sense of this before you go on here. So now, I'm going to focus on, I've got this length of 6 feet. I know that's 8. Now, I can figure out what my length of this red question mark that you see here. I can figure out what that length is. Okay? So I'll use the Pythagorean theorem again. A squared plus b squared equals to c squared. Now, what is my length of, which is my hypotenuse? Let's begin with that. Once again, the hypotenuse is where the right angle is. If this is 90 degrees, this has got to be 90 degrees as well. And so once again, it's pointing to my hypotenuse, which is the unknown. Okay, so that's my c. So I'm just going to put c squared as the unknown. My a squared, why don't we just start with this, the 8 squared. And what is my b squared? B squared would be the 6 that you see here. Okay, and so we add a squared, 8 squared plus 6 squared equals to c squared. 8 times 8 is 64. 6 times 6 is 36. C squared is the unknown. Okay, you add them together, you end up getting 100 equals to c squared. What do I do next? I need to take the square root of both sides, as you know, and my c is 10. Okay, so the c is 10 feet. C equals to 10 feet. So is that my answer? Is that what I give? Well, go back to the original question again. The original question was, what is my perimeter? Not what the length of C was, right? Or the length of AC. So you need to go back to the original problem, which is the perimeter. And how do I figure out the perimeter again? The perimeter is the sum of the three sides. We're looking for the perimeter of triangle ABC. Okay, triangle ABC. So the length of this here was 21. So I need to add the 21 feet. The length of B to C is 17. I need to add the 17 feet. And the length of A to C is the 10. You need to add up the 10. Add them all together. It's to find out how many feet it is. That's an 8, 48. So my answer, my grand answer, my final answer is 48 feet. 48 feet. Okay? That is the perimeter of ABC. You gotta always make sure that you are answering the question, the original question that was posed. These multi-step problems, you end up going so far into it, doing all these different things, and sometimes you kind of lose sight of what the original question was. And if this was a test, a multiple choice test, this would probably be one of your answer choices, this 10. 15 could have been an answer choice as well. 6 could have been an answer choice as well, because test makers do like to trick you, and the options that you see are not just random numbers. They are numbers that would appear if you were working out this problem here. Okay, so if you have any questions, rewind once again. Write down questions for me when you come back from spring break, and you can pose those questions to me. I'll be glad to answer them for you. And thanks once again for watching this video here. Enjoy the rest of your break. Okay? Alrighty. Bye-bye.